All right, thank you for joining us today. And in this video, we are going to solve these examples, right? And then the last question, which is question 10, that I'm going to give it to you will be a bonus question that is going to cover everything that we are going to do from question 1 to what? Question 9. We learned from the previous video how to differentiate a polynomial function, radical function, exponential function, natural log function, and then log function. So we are going to apply the idea to go through this example, and then in the next video we are going to look at how to differentiate a trig function, a non-constant base function, and we are going to also learn how to use the change rule. Let's jump right in. So we learned how to differentiate a log function, right? So let's try this. You can pause the video and then also try to see if we are on the same page. So what was the idea of differentiating a log function? So we said for us to differentiate a log function, all we just need to do is f prime of x is equal to 1 divided by what is inside the parenthesis. So 1 divided by what is inside the parenthesis here. So 1 divided by what is inside the parenthesis. But I'll put it what? In parenthesis again. Times length of the base, which is 5, right? So 1 divided by what is inside the parenthesis here, which is x squared plus 1, times length of the base, all times the derivative of what is inside the parenthesis. Very simple. So that is what we learned from differentiating a log function. So let's go through the process. We are going to have 1 divided by x squared plus 1 ln of 5 times, now when I differentiate this is a polynomial function, right? We learned how to differentiate a polynomial function. So when I differentiate x squared, what am I going to get? 2x by using the power rule. When I differentiate a constant, I get 0. So this is going to be this. And then if I want to simplify, I'm going to have 2x divided by x squared plus 1 ln of 5. So this is what we are going to get for the first function. Nice. So this is how we differentiate log function. Let's look at this one too here. This function here, we have ln of x and then log of x, right? So we know that this, we need to use one of the properties that we learn under derivative, right? So here we are going to use the product rule. So as I said, if you know how to do it, you can go straight by doing it straight. If you don't know how to do it, you can choose your A, you can choose your B, then you do it together, right? So let me choose A and B. So my A is equal to ln of x, my B is equal to log of x. When I differentiate ln of x, what am I going to get? So I need A prime. So we learned from the previous video that if I want to differentiate a length function, then all I need to do is I need to take 1 divided by what is inside the parenthesis, all times the derivative of what is inside the parenthesis. So 1 divided by what is inside the parenthesis, which is x, all times the derivative of what is inside the parenthesis, which is x. So this is going to give us 1 divided by x times, when I differentiate x, we get 1. So we are going to have 1 over x. So we all know that when I differentiate ln x, I get 1 over x. But you need to know how we got the 1 over x, so that if a function is given to you and it's not just ln x and let's say ln x squared, you can use the process to also find it. Let's look for B. So we just learned how to differentiate a log function here. So we said 1 divided by what is inside the parenthesis, which is also x, times length of the base. So what is the base here? Anytime a log function is given and then the base is omitted, we are assuming that it is what? 10. So this one is going to be length of 10 times the derivative of what is inside the parenthesis. So this is going to give us 1 divided by x ln 10 times 1, which is the same as 1 divided by x ln 10. So what is the difference here? The only difference with this and this is now we multiply this one by base of the base of what is the log here. By here too, actually we multiply by the base, but the base here is e, and we learned that ln e is equal to 1 and e to the power ln is also equal to 1. So that is the idea. So now let's do the cross multiplication. This will multiply this and this will multiply this. So by adding them together. So what will be J prime? J prime of x will be equal to a b prime plus b a prime. Addition is commutative, so you can bring this one here first or this one also here first, right? Any of them works with product rule. So what is a? A is ln of x. What is b prime? So this is a. B prime is what we have here, which is 1 divided by x ln of 10 plus what is b? B is log of x. So log of x times what is a prime? A prime is 1 over x. So we are going to have 1 over x. We can stop here, but if I want to simplify, I can write this one as ln of x divided by x ln base 10 ln 10 plus log of x divided by x. So this is what I'm going to get. So as I said, if you know how to do it and you don't want to go through by doing this, then you can just do it straight. But you need to be careful whenever you are doing it. So for example, if I want to go straight, J prime of x will be equal to, if I want to maintain a first, then when I maintain ln x, I'll multiply by when I differentiate this. So if I know how to do that, this one will be 1 divided by x ln of 10 times when I differentiate what is inside the bracket, I'll get 1. So I just multiply by 1 plus now I maintain log x and differentiate ln x, which is going to give us 1 over x. When I differentiate what is inside the bracket, I'll get 1. And when I simplify, I'm going to get what is here, the same thing, right? So that is the idea. You can just go straight, or you choose your A, B, and then you find A prime, B prime. Somebody can choose this one to be F, this one be J, F prime, J prime. You still the same thing, then you go your way, right? Some of the functions are very complicated, and you just need to pick them so that you can get them right. Right, so now let's look at the third one. Let's look at the third one. We have a function f of x, which is equal to x squared plus e to the power x plus ln of x squared. So we know how to differentiate each function, so we are doing them together. This is going to be f prime of x to be equal to, so this is an polynomial function, so power rule, we get 2x plus, now we learned how to differentiate an exponential function. We said maintain the function, then multiply it by the derivative of the top. That's all. That's how we differentiate an exponential function, right? Maintain the function, multiply it by the derivative of the top. So plus, we learn how to differentiate a ln function, 1 divided by what is inside the parenthesis, which is x squared, times derivative of what is inside the parenthesis, which is very simple. So, okay, here, let me use the power rule for this one too, so that it's going to be okay for us. So let me use the power rule. So power rule, 2 drops down, 2 minus 1, right? So that we can simplify. So this one is going to give us 2x plus, when I differentiate x, I'm going to get 1 times this. So I'm going to have this times 1 plus 1 divided by x squared times, when I differentiate x squared, I get 2x by the power rule. So I'm going to have 2x plus e to the power x. Then one of the x here will cancel one of the x here. So I'm going to have plus 2 divided by x. Nice. So this is how we are going to differentiate the function, and this is the results that we are going to get. Let's look at 4. 4 again, we have product rule. So I'll do my a and b. So I'll change it. Let me make it f. If you want to use a and b too, it's the same thing. So So the first one I use A, I want to use f and gen. So f is equal to ln of x, gen is equal to e to the power x. So what is f prime? F prime is differentiating ln x. Right now we know that when I differentiate ln x, I get 1 over x. So that is some of the things that you need to get used to. Like, okay, when I differentiate, this is what I'm getting, right? When I differentiate e prime, what am I going to get? So when I differentiate e to the power x, what am I going to get? E to the power x, as we just even learned it here. When I differentiate e to the power x, I get e to the power x. So some of the functions, you need to just have them off head, and that's all. So what is gen prime of x? F gen prime plus gen f prime. So let's go. F is here, gen prime is here. So I'm going to have ln of x e to the power x plus gen is here, f prime is also here. So I'm going to have e to the power x divided by x. Very simple. Very simple. So it's always good for you to know how to differentiate individual function. So if I'm using the product rule, boom, I'm going. Here we were just using the sum rule, right? So we differentiate individual functions. This is the product rule, so we need to go by the product rule. This one too, you can do it straight if you know how to do it, right? Good. Now let's look at 5. 5, which rule are we going to use? Okay, we are going to use the quotient rule, right? And as soon as I identify that I'm going to use the quotient rule, another question is, can I differentiate the individual function in this function? Yes. So since we can do that, then we don't have a problem. I just know that I'm going to use a quotient rule. So quotient rule, I'm going to make the top u and then the down v, right? So what's the quotient rule? F prime of x will be equal to vn u prime minus u vn prime divided by vn squared. Here, the minus count a lot. I cannot bring this before this. So when you do it like u vn prime minus vn u prime divided by vn squared, if the results that we are going to get from this is 2, you are going to get minus 2. So here, make sure that you know how to write the formula down. The denominator first, right? Maintain the denominator, differentiate the top, minus, now maintain the top and differentiate the denominator, all divided by the down square. That is the denominator. So since this is equal to u over vn and is this, then I need u, right? I need vn prime. So that's what I'm going to look for. So I need u is equal to this. I need vn is equal to this. So I need u prime and vn prime. Somebody too can say that, okay, this is equal to f divided by gen. This is also the same as gen f prime minus f gen prime divided by gen squared. Any of them works. Any of them that you want to use is going to work out for you, right? Good. So don't worry with. So now what is u? U is equal to 2 to the power x. What is vn? Vn is equal to ln of x squared plus 1. So now we need to differentiate these functions, right? So what is u prime? Now we learned from the previous video that now you see that when we were differentiating e to the power x, we just said e to the power x times the derivative of the top. But we learned that when the base is no e, we need to do something about it, right? So what is the something that we are going to do about it? Now here we maintain the function 2 to the power x times the derivative of the top, which is x, right? So maintain the function, take the derivative of the exponent here. Now don't forget, here we are going to multiply it by ln of the base, which is what? 2, right? But here we saw that when I multiply this one by ln of the base, which is e, this is going to give us 1. So there was no need for us to even think about it. Very simple, right? Good. So that is the idea. So when I simplify this, I move this one down small. When I simplify this, I'm going to have 2x times 1 times ln 2. So this one, you don't need to punch it on the calculator to get what is ln 2. Just leave it like that. Then now let's talk about differentiating Vn. So what is Vn prime? So we learn how to differentiate a ln function, 1 divided by what is inside the parentheses times the derivative of what is inside the parentheses. Very simple. So this is going to give us 1 divided by x squared plus 1, or times this one will be 2x. Simplify, and we are going to have 2x divided by x squared plus 1. So this is what we are going to get. So now what will be f prime? Let's use the formula. So we need Vn. So what is Vn? Vn is here. So I'll write it down. So ln of x squared plus 1 times, we need u prime. U prime is here, and we had this. So I'll multiply it by 2x ln 2 plus, minus, we need u is here. So I have u, which is 2 to the power x. Then we need Vn prime. Vn prime is what we had here. So I'll multiply this guy here by 2x divided by x squared plus 1. Don't forget, all of them divided by Vn squared. What is Vn? This is Vn. So we are going to do that. So Vn, what is this, all squared. We can leave our solution here without doing further simplification, but we can also try to simplify this too as well. We cannot cancel anything here because we have ln here, but we don't have ln here, so we cannot cancel. We can actually factor one of this out, which is also possible. And yeah, so we can just leave it here. Yeah, so this will be the derivative of the function, right? You can decide to factor this one of them out, so that it will be left with this times this and this divided by that. And you can bring this one down by multiplying this one by this. It's also the same thing, but this is what this is how I'm going to leave it. Final results, right? Now let's look at 6. 6 to we want to find f prime. This is the sum rule, and this is the what? The difference rule. So let's go. What is f prime of x? Now we need to differentiate 2x. So as I said, if you have a constant multiplying the function that you are coming to differentiate, or dividing, you just factor it out. So when I factor 2 out, it will be left with x. When I differentiate x, what am I going to get? 1. Good. It's good that you said it. Plus 4. So 4 is also multiplying the function that we want to differentiate, because 4 is a constant. So I factor it out. Then I follow the idea of how to differentiate an exponential function. So we said maintain the function times the derivative of the power, right? Which is minus 2x. Good. So I maintain the whole function here. Then I differentiate the top. Then minus. Now we learn how to differentiate this when the base is not e. So you see that this one, the base is e. The base is 4. So this is going to be, I'll maintain the function, right? Then I'll take the derivative of the top, which is x plus 1, but I'm going to multiply it by ln of the base. Good. So maintain the function, differentiate the top, take ln of the base. Here we don't concern, as I said, we are not concerned with the ln of the base, because ln of the base is 1, right? So this is going to give us 2 plus, when I multiply this and this, I'm going to have 4e to the power minus 2x. And when I differentiate this, I'm going to have minus 2 minus, I'm going to have 4x plus 1. When I differentiate this, I'm going to get 1. So times 1 times ln of 4. So simplify plus, I think 2 minus 2 times this is going to give us minus 8e to the power minus 2x. Then when I multiply this one, I'll get minus 4x ln this, and then ln 4. So this is what we are going to get at the end of the derivative. Let's look at 7 and 8. I'll do the 9, then I'll give you my 9th question, which is question 10 for you to try. Then you drop your final result in the comment section. Right. So f prime of x will be equal to, so polynomial exponential function. This is exponential function, but it is what? Constant, because here is x, there is no x here. So we know that when you differentiate a constant, you need to get what? 0. So here you need to be more, you need to see it very well. So when I differentiate s cubed power rule, 3 drops down, I maintain x to the power 3 minus 1. Minus, we want to use the exponential rule. So exponential rule says that maintain the function, take the derivative of what is on the top, which is x squared. Plus here, if you don't take care, you will be like, okay, I maintain the function times I differentiate what is on the top, which is true. Okay, it is true. So I'll show you how this is also true. So this is going to be 3x squared minus ex squared. Then when I differentiate x squared, I'm going to have 2x plus pi. Now, when I differentiate pi, what am I going to get? We know that pi is like, is it 3 point something something? Yeah, 3.142. So like 3 point something means that it's a constant. So when I differentiate a constant, I'm going to get this one to be 0, and 0 times this one will be 0. So that's why I'm saying that this is a constant. So you don't even need to do this. All I need to do is when I differentiate the constant, I'm going to get 0, and that's all. Good. So this is going to be 3x squared minus 2x e to the power x squared. Yeah. So this is what you are going to get at the end of the day. Good. If you have questions, you can drop them in the comment sections. I'll try and do it. So this is the quotient rule, right? So my u is x, my vn is equal to e to the power x. When I differentiate x, I get 1. When I differentiate e to the power x, I get that. So what is gen prime of x is equal to vn u prime minus u vn prime divided by vn squared. So this is going to give us vn is e to the power x. What is u prime? 1 minus what is u x? What is vn prime? E to the power x divided by vn squared. So e to the power x all squared. This is equal to e to the power x minus e to the power x divided by e to the power x. Remember, if I have this one to be squared, I can write that e to the power x times e to the power x. So I just want to do some small simplification here. E to the power x out. So when I factor this one out, it will be left with 1. And when I factor this one out, it will be left with x divided by e to the power x times e to the power x. So that one of this will cancel this, and then we'll be able to get 1 minus x divided by e to the power x, which is here. Right. So this is the 8. Let's look at the 9. Then I'll give you the 10. So this is also a product rule. Let's go through fast. If I let this one to be, let's say, gen and f, right? Then my gen will be equal to root of x. But I showed you how to making sure that you rewrite the radical in a form that you can apply the power rule. So this is the same as x to the power 1 over 2. Then f will be equal to e to the power minus x. So what is gen prime? Power rule. 1 over 2 drops down, right? Then I maintain x to the power 1 over 2, then I subtract 1. So this is going to give us 1 over 2 minus half, right? So I showed you how to do these fractions. Then f prime will be maintain the function times the derivative of the top, so minus x, which is going to give us e to the power minus x times when I differentiate minus x, I get minus 1. So this is going to give us minus e minus x. Good. So now what will be, we are using the product rule, right? So h prime of x will be equal to gen f prime plus f gen prime. So gen is this, f prime is also this. So we are going to have minus x 1 over 2 e to the power minus x plus this is f and this is gen prime. What is gen prime? Gen prime is here. Good. So we are going to have 1 over 2 x to the power minus 1 over 2 times e to the power minus x. So this is what you are going to get at the end of the day. Good. So I'm going to give you question 10, which is going to combine everything that we've done from question 1 to question 9. Everything is inside. So do this and please send your final results in the comment section. So we have a polynomial function, we have a radical function, we have a log function, we have natural log function, we have a exponential function where the base is not e, and we have the exponential function where the base is e. So all of them are here. 1, 2, 3, 4, 5, 6. So try and do it and put your final result in the comment section. See you in the next video. As I said, the next video we are going to talk about trig function, chain rule, and then non-constant base function. Right. See you in the next video.